Hello everyone and welcome back to this next lecture. So in this lecture I'm going to talk about the target students of this course. That is, who would this course typically be for? So before I get started with that question, I'll talk about some aspects of this course which will describe to you who would be the target students of this course. So as I've already said in the previous lecture, in this course we'll be using C programming with the Code Composer Studio IDE for programming the microcontroller. Now, in modern times, this is not strictly necessary anymore. There are many graphical tools that can convert your controls, which have been developed in Simulink or in many other simulation softwares like Plex or PSIM, into C programs, and these C programs will be compiled into assembly code, which is downloaded onto your microcontroller. So without using Code Composer Studio or something which is strictly from Texas Instruments, you can convert your simulations or whatever control code that you write in simulations directly into microcontroller object code. Now, such graphical tools are very popular in R&D, right? And the reason is simple, because researchers need to stay focused on control design and other kinds of system analysis rather than write C programs every time. So for example, let's say you want to implement a new control strategy. You do not want to spend hours and hours writing C programs just to implement that control strategy. It would be much simpler if whatever you do in a simulation can be directly compiled and downloaded onto the microcontroller. So therefore, in R&D, these kind of graphical tools are extremely useful and are very popular. But when it comes to final firmware development, and this I mean product firmware, which will actually go into the final product, in that case, the firmware is usually written either using C programming or with assembly language. And therefore, for this reason, if you want to become a firmware engineer or an embedded systems engineer, or even for that matter, a power electronics design engineer, a deep understanding of microcontroller architecture and the ability to read technical documentation to understand the depths of everything that is available with the microcontroller, and these things will eventually translate into strong programming skills where you can now write C programs in order to program the microcontroller. And all this knowledge will make a very strong foundation for a young power electronics engineer entering the industry. So again, as I said, for young engineers, and especially these who are just graduating with a bachelor's or a diploma, the first entry jobs are usually firmware engineer or product engineer. And these kind of positions are a great way for young engineers to enter the power electronics industry. And in these kind of positions, the knowledge of programming, the knowledge of electronics, a deep knowledge of microcontroller architecture and the architecture of peripherals, along with the ability to program all these devices using C programming, will make a very good qualification for all these entry-level positions. And similarly, if you ever plan to work in a startup, you always need to be an all-rounder, because in startups, you usually don't have a demarcation between an R&D engineer and a firmware engineer. Quite often, everyone does everything. So the R&D engineer will also be writing C programming and will be controlling the microcontroller as well as designing control algorithms. So once again, if you ever plan to work in a startup, a strong foundation in firmware development will make you a very strong asset in such a small company. And finally, of course, besides working engineers, another group of students who would benefit from this course are graduate students. That is, those who are doing their master's or their PhD. Because in such cases, you can now use this knowledge of microcontroller programming for your graduate projects. Because quite often when you're working in a university, your budgets are not extensive, and therefore you have to be able to use low-cost microcontroller kits rather than be using expensive kits which actually come with everything. And therefore, in that case, once again, deep knowledge of microcontroller architecture and C programming will make your life as a graduate student extremely simple. So In this course, I will be going into the detail peripherals such as GPIOs, that is general purpose input output pins, EPWMs, which are the enhanced pulse width modulation pins, EDCs, which is the analog to digital converter, and also timers. And most importantly, I'll be telling you how you can configure these particular peripherals using interrupts, which means now you can actually have your control algorithms running inside interrupt service routines along with the actual outputs and inputs from these particular modules. So this course will introduce each and every peripheral, giving the context of a power electronics application. So I will describe a sample power electronics application, and I will say that in this particular application, we need to use this particular peripheral in so and so manner. And with that particular application, I will now describe the peripheral and will also describe how the project can be created for controlling that particular peripheral. This course, however, will not describe how to implement control such as PI control for power electronic converters, and also it will not describe how to use the control law accelerator. So these are advanced concepts and I hope to cover them in a future course, but not in this course. So this course will describe how you can program both processors, because one of the advantages of this particular microcontroller kit is that it is a dual processor microcontroller, which means there are two CPUs. There is a CPU 1 and there is a CPU 2. And both these CPUs can be programmed simultaneously, and you can execute code simultaneously and independently in the two CPUs. And most importantly, the peripherals, all these peripherals, the GPIOs, the EPWMs, the ADCs, the timers, these are all shared between the two processors. So therefore, you can actually use all peripherals between the two processors. Therefore, you can implement independent control algorithms on the two processors if you so choose to. And most importantly, even though the two processors can be independently programmed and the programs can be independently executed, these processors can also communicate with each other. So therefore, you don't just have independent execution, you also have coordinated execution, which is also possible with this particular microcontroller. So this course will describe several approaches towards how these microcontrollers can be used. So for example, Texas Instruments provides several libraries, such as the driver libraries, which provide several useful functions which make our life easy. And I will show you how some of these functions can be used, not just by us, but also through the use of sample example projects, which are provided by Texas Instruments. But besides using these library functions, I will also show you how you can work directly with the registers provided with each and every peripheral. So you can configure each and every peripheral by just setting and changing the particular registers that affect these particular peripherals. So this way you get complete control over the microcontroller and completely understand how each and every peripheral can be used through each and every specific register. So this gives you a basic understanding of who will benefit from this course. Just in case you are wondering whether this course is for you, then this lecture was to describe why this course is going to emphasize on certain aspects of the microcontroller and why the content of this course has been presented in a certain manner. There are several other advanced tools which are available, and I have not covered them because this course is for young engineers entering the industry. This course is not for R&D specialists who are just trying to quickly implement controllers, as those people have other resources available to them. I believe that it is young engineers who are entering the industry who do not have sufficient resources on how to use microcontrollers for power electronics, and that is the purpose of this course. So if any of this was not clear to you or you have any other doubts, please post in the Q&A forum and I'll be happy to help you. Otherwise, I will see you in the next lecture. Thank you so much for listening and see you soon. Goodbye for now.